Good morning or afternoon, and welcome to the North Meck High School Algebra 1 EOC video clips. Today's clip is 4.01, Use linear equations to model problems. This is video number 9. Now, goal 4 is the highest weighted goal on the EOC. So you need to work really hard in goal 4, particularly 4.01. Problem number 1, let's get started. Again, use linear equations to model problems. So you see problems up here, big word problems. You're expected to be able to do those. All right, number 1, Denisha bought a car for $15,000 and it depreciated linearly. After 3 years, the value was $11,250. What is the amount of depreciation? All right, there are 2 ways you can do this problem. The first way that I'm going to present is to simply write down order pairs and find the slope. Now, if she bought the car for $15,000, that means that you have an order pair of 0, 15,000. 0 represents the amount of time that it passed. She bought it, so no time had passed. She just bought it. It was a new car, $15,000. So no time had passed. 0, 15,000. The other point is then 3 years, 11,250. So this is 3 years, 11,250. So again, the first point is 0, 15,000. The second point is 3 years, 11,250. Now, when we talk about what was the amount of depreciation, what we're talking about is slope. Slope, how quickly it's depreciating. That's your slope. So now remember, slope is found by subtracting your y's, and put that on top, so 11,250 minus 15,000 divided by, subtract your x's, 3 minus 0. So again, to find your slope, you're going to subtract your y's, put that on top, subtract your x's, and put that on the bottom. Now you know this formula as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's a very familiar formula for you. You know the formula for slope. Now we can just simplify this. M is equal to, take your calculator, type in 11,250 minus 15,000. Minus 15,000. You should get 3750. 3750. But let's type that in just to check and make sure. All right, we got 11,250 minus 15,000. Okay, we get negative 3750 divided by 3 minus 0, which is 3. So we have M equals negative 3750 divided by 3, which is negative 1250. So the amount of depreciation is 1250. It's negative because of the word depreciation. It's going down. And we know that when you buy a new car, as soon as you drive it off the lot now, we know that it depreciates. So we're not surprised that even though she started out buying that car at $15,000, 3 years later it's only worth $11,000 because it's depreciating. When we say depreciate, that means that your slope is going to be negative. Your slope is going to be negative. If it was appreciate, then your slope would be positive. All right, number 2. Jim is selling hot dogs. It costs $250 to purchase everything to make the hot dogs. Okay, so that's everything to make them. Jim sells the hot dogs for $2 each. If his hot dogs are selling, which equation models his profit? All right, so his profit, Jim's profit, is going to be equal to $2 each for each hot dog. So 2H, if H is hot dog, so $2 per hot dog, but Jim owes $250. So we're going to subtract off $250. So his profit is 2H minus his initial cost of $250. Here you see slope again at $2 each sitting in this slot. This is an example, even though they use different letters, this is an example of y equals mx plus b. Y equals mx plus b. That's why it sits in linear equations. Again, this as well it says the word linearly in it. So you're looking for a linear equation, you're looking for slope. Now, I told you that there were two ways to do this problem. We'll look at another way to do that problem in problem number 4. All right, let's go on to 3. 3 is not really a problem. I just wanted to show some words that you need to look for and what they mean. If you see that word change, that's your slope. That means slope. Average rate of change, average means slope. These are different words that mean slope. Okay, slope. So flat rental fee, if you have a flat rental fee, this is without anything additional. Without anything additional. Like your days. You usually have a flat rental fee of like $26 plus so many, I'd say minutes or quarters or dimes or 15 cents per mile, something like that. Your 15 cents per would be your slope. Your flat rental fee is where you're starting. Now, they will give you problems and they will ask you, what does the x-intercept represent? For example, if they say x represents the value of her sales and y represents your total earnings, what does the x-intercept represent? Now, if you are talking about your x-intercept, that means your y is 0. So the x-intercept represents no earnings. And so you come down your multiple choice and you look for the one that says no earnings. Her total sales with no earnings. That's your x-intercept. Your y-intercept, in this particular example, if they were asking for the y-intercept is where x is equal to 0. So your y-intercept would represent no sales. 0 sales. So again, they will tell you what x and y are. But if they look for the x-intercept, that represents nothing for whatever y is. If they ask for the y-intercept, that it represents nothing for whatever x is recorded to be. So again, my x-intercept would represent 0 earnings. My y-intercept would represent 0 sales. Alright, now in problem number 4, I want to use the graphing calculator to do problem number 4. Alright, in 1977, the price was $175. Alright, so for that one, I'm going to put 0, 175. Notice I did not put 1977 here. Okay, you are not to do that. That's your initial starting place, so you let that be 0. You let your initial starting place be 0. If the problem does not tell you, most of them will, you let their initial place be 0. Do not put 1977. Alright, now, for 2004, I need to subtract 2004 minus, or subtract 1977 from 2004. Why? Because if 1977 was my starting point, I want to know how far away this was. So what I'm going to do is type in 2004 minus 1997. Sorry, 1977. All right, I get 27. So this point is 27, 15. 27, 15. Now the question is this. If it's linear, what is the price in 1998? What I can do with this is instead of, now one thing I can do is find the slope and then do y equals mx plus b and plug the number in. The other thing that I can do with this is put the x values in as L1. The y values in as L2. And that's what I'm going to do. Hit stat, edit, I'm going over to L1. Okay, I'm going to put 0, 27 in there. 0, enter, 27, enter. Alright, I'm going over to L2 on my calculator. I'm going to type in 175, enter, 15, enter. Alright, I have the points in. Now I'm going to hit stat, calculate, and I'm going to come down to linear regression. Hit enter, and you have y equals negative 5.9x plus 175. You're not surprised by negative 5.9 because obviously this is decreasing. It started out at 175. The price started at 175. It's now down to 15. I bet you that could model maybe some sort of cassette tapes or something. Something that's drastically decreasing, or maybe a CD player or something, video recorder. All right, now, the question is, what was the price in 1998? So now you need to say 1998 minus 1977 to get 21 years. So that means that if I put a 21 in here, I have the price for 1998. Again, 1998 minus 27, the original, to get me my 21. I'm going to put a 21 in here. So I'm typing in negative 5.9 times 21, and then I'm going to add 175. Hit enter, I got 51.1. So y in 1998, it was 51.1. There are so many ways you can do this problem. You could get this equation, put it in under y equals, and trace your graph to 1998. You can look at your table for 1998 and read off the y. But again, what was the price in 1998? 51.1. The biggest thing here is the fact that you do not put 1977 right here. You put 175. And then 27 years later is 2004, 15. And then 1998 would be 21 years later, so 51.1. All right, my suggestion in this one is not to do additional problems. My suggestion in the linear video is that you go back to the original problems that you see, pause the tape, change the numbers, rework the problems. For example, this time, let's say that Denisha bought a 300, and you make this 36,000, okay? And 3 years later, it's 25. And do the problem again. So what I'm asking is that you go back into each one of these 3 problems and change the numbers and rework the problems. That's the best way because all of them work the same way, and I need you to see that. If you submit that to your Algebra 1 teacher, he or she will be happy to give you credit. Thank you so much, and have a good afternoon.